So welcome to Suggest Projectile Velocity. In this video we're going to take a closer look at how projectile flight works. By the end of it you will have a modification to your tank where you actually have a launch speed parameter that will be passed all the way from the tank down to the aiming component and then ultimately printed out on the console. We will also be taking a look, and your homework will be to look carefully at this very useful method Unreal provides called Suggest Projectile Velocity. So let's take a look at how all this works. So let's talk about how we're actually going to get our projectile to its destination. What we need to do now is to start thinking about having this barrel move itself into the correct position to end up hitting the world space aim, if possible. It may not be possible, of course, like it probably isn't possible in this case. Hitting the top of that hill might be unreasonable, but I could certainly hit this tank. Depends on the launch speed. So let's talk about launch speed and launch velocity, make sure we understand that, and then go from there. Just stop it running. Got a couple of slides for you. Okay, so let's talk about the difference between projectile speed and velocity. Sorry to those physics nuts out there who already know this, but for everybody else I think it's important. So if that vector is some three-dimensional vector, which is the launch velocity, basically it's the direction of the barrel. If it has a length of 5, that means our launch speed is 5. The velocity vector has a direction, which is the direction of the barrel, and a magnitude, which is its length, which tells you how fast you're launching it. Now, 5 is a very slow launch. We're not going to be launching our projectile at 5 centimeters a second. It'll kind of just flop out the end of the barrel. But I just want to do it so that this thing is vaguely to scale. So if that's the launch velocity vector, then there's another vector called the launch direction vector, and it's a unit vector, which means it always has a length of 1. And that's what we're really interested in. We need a launch direction vector to know the direction that we want to point our barrel in. We don't actually care when we're pointing the barrel how fast the projectile is going to launch. We have to know how fast it's going to launch to do the calculation. But all we need to actually point the barrel is just a 360-degree location, somewhere on the surface of a sphere. And that thing has a length of 1. That's called a unit vector. And so the difference between those, or the divider between those, 5 over 1 is 5. So the launch speed is 5 in this case. If the launch speed was 10,000, then the launch velocity vector would be 10,000 times longer than the direction vector. It's called a unit vector, simple as that. Hopefully that makes sense. I wouldn't worry about it too much. It'll just give you a bit of background for when we actually use the methods. So there are 2 projectile arcs, which is kind of fun. If you launch something with a given launch velocity, i.e. that same green arrow, then you fire it, off it goes, along a parabolic path. Okay, they're not quite parabolic, as I said, but you get the idea. Then it'll hit something in the distance, hopefully another tank if you're lucky. But there's also another angle that you can fire it at for the same launch speed. So a launch velocity vector that is in a different direction. It's going to be in the same left and right plane, but it's going to be up. It's going to be a higher toss, higher lob, if you like, and it's going to have the same length. Both those green arrows are the same length, or they may not look it, but they are. And what would happen then is you'd end up in the same place. There's always 2 solutions to how you get to that other tank with your projectile. You either go via the high arc or the low arc, and that'll come up in our method as an option as to which we choose. We're going to choose the low arc. The reason it's quicker. The projectile will get there much quicker along the low arc. Let's take a look very briefly at Wikipedia's page. This is all in the notes, but you can look at trajectory of a projectile. So if we go there, scroll down to this bit, conditions at the final position, or you can just click here, conditions at the final position. Where's that? I can't see it. There. Okay, then you've got this diagram, and this will give you an example. Let's focus on trying to hit something that's 5 meters away, which is this bit here. And what that's saying is you can either lob it at 15 degrees, it will get to 5 meters, and it'll only spend half a second in flight, or you could lob it at 75 degrees. It would get to the same distance, coming down much more sharply, but it would take 1.93 seconds, nearly 4 times as long in the air, much easier for the other tank to get out of the way, etc. So you're much better off with using the low arc in these cases. Okay, so you can read more about that if you want to, just bear in mind that there are 2 arcs. So let's see how this means that we actually use the method in question. The method we're going to look at is suggest projectile velocity. Now I'm not just going to leave you to it unless you're really keen, but I'm just going to set you up before we go ahead with that. So where are we going to set all this stuff? Well, there's lots of ways of doing this, but what I'm going to do is suggest that on the tank we have ourselves a variable which is a firing category variable, so it comes in here under firing, and it lets us set the launch speed. So if you want a micro challenge, set up a float called launch speed, put it in the firing category, make it available on the tank blueprint. And I'm just going to go ahead and do that now. It's not that complicated, hopefully. So in order for it to be visible, it needs to be a U property. It needs to be edit anywhere. That's the annotation we need. The category equals firing, just to group things together nicely. Then it's going to be a float because it's not whole numbers. Launch speed, because the speed is just a scalar, it doesn't have a direction. And I'm going to say 10,000, and this is a sensible starting value. In fact, let's use 100,000. I'm just trying to guess here, but we'll try and pick something as a vaguely sensible starting value of 100, or is this 1,000 meters per second? Because it's in centimeters a second, so there you go. Strip off the centimeters, you get 1,000 meters a second. That's a few thousand mile an hour, maybe 3,000 mile an hour. That's probably about right. It's a supersonic tank shells going like Billy-O. It's probably not far off. But this is just a sensible default, and it'll of course be overridable in Blueprint. So there you go. We have a launch speed. Now, when the tank CPP calls the aim at method, let's give ourselves some more space. Previously, it's only said aim at a particular location, but you can't solve that. You actually need to know the launch speed. It's no good trying to get to a particular location without knowing the speed, because there's a whole host of combinations of speeds and barrel angles that will get you to the other tank. So from the outside of the tank, in terms of the tank's public interface, it's fine that we just say to the tank, hey, aim at this thing. It's not my business from the outside of the tank what combination of projectile velocity and barrel angle you use, right? But from inside the tank, it's going to have a notion of launch speed, and it's going to pass that notion of launch speed down to its tank aiming component. So that's what I'm doing there. I've made a private member called that, passed it down. Let's just compile and make sure that's visible on the blueprint as we'd expect it to. What I'm hoping will happen is on the tank BP here, in the right-hand side under details, when this compilation finishes, a section should pop in called firing, and then it'll have a launch speed and it'll say 10,000. If I do it right, what have I done? Function does not take two arguments. Okay, so what I've done, of course, is I've sent in a second argument here, which is why it was complaining, but I haven't modified the tank aiming component yet. So let's just do that. That's going to be quite simple. In the tank aiming component's aim at method, let's take in a float called launch speed, because we're going to need to know that. And then in the implementation of it, let's just go float launch speed. And while we're here, I'm going to get rid of all this stuff, all this logging, and I'm just going to say firing at %f, because we've got a float directly, and then all this rubbish can go away, and we can just say launch speed. Okay, so this will prove that this launch speed has made it all the way through to the component. Let's try now. Hopefully that all made sense. Relatively simple. I'm just setting a variable on the tank, delegating it down to the tank aiming component, which is in turn printing it out. So we were saying that hopefully a firing section will appear in the details tab of the tank. It just did. It has a launch speed of 100,000 rather. Let's play. You see it firing at 100,000. Now let's go ahead to the tank blueprint and change that to say 4,000 and play. We have a crash. Now I think that crash is just Unreal being awkward, to be honest. I can't see any reason. We haven't used unprotected pointers or anything like that. So let's just grin and bear it and say, darn Unreal, you crashed, but at least you're powerful. I kind of forgive you. Let's go to 4,000, save, compile, run again. And there you go, the 4,000 is going through. So the blueprint value is overriding, as we'd expect, the C++ value. I have no idea what the sensible default is. So what we should do at this stage in our code is say to ourselves, admit that we have no idea, and say to do, instead of saying that, sensible starting value, we say to do, find sensible default. We have no idea until we start firing the projectiles whether this is reasonable, even in the right ballpark. So we need to later find a sensible default, then leave it to the designer to tweak that value over here. Okay, enough said on that bit. So we are pretty much ready to go on this. Let's just continue to build up the awareness of this method, and then I think we will leave the actual writing of this to the next lecture because it's going to be too long otherwise. So let's just start looking at this suggest projectile velocity methods. Two ways to get a view on this. One is to look at the C++ documentation, which you can just do a Google search for suggest projectile velocity, and you get two answers. One is, you'll see this one here, and if you go to that one, the one that doesn't say you gameplay statics, etc., then you'll find it's talking about the blueprint probably. Here you go. It's actually got much more interesting and useful information about what all these parameters do. So do have a look at those. In fact, that's going to be your homework before the next video, is to go and read about this. But also keep a close eye on, pretty much keep them next to each other like this. Keep a close eye on the other documentation. you'll find in Google, which is where it actually tells you about the C++ method. Because you'll find that you don't, for example, have a world context object on the blueprint. You do have a start location, you do have an end location. It doesn't output a toss velocity in the same way. You see, the blueprint's a little bit different. It does have an override gravity, etc. And there's more things, a few more on here. So basically, make sure that you've got some idea what this guide does. It's designed for first-person shooters, for giving affordance, as we call it, when you say throw a grenade into the distance. It's like a grenade landing marker. That's the point of using this. It's working out where your grenade would land if you fire now. And that's why they use the word toss, because you toss grenades. Well, we don't really toss tank shells. That sounds a bit wet. We fire them with gusto. So we're going to call this launch speed, but you get the idea. So that's your homework. I want you to get to these two documents by searching Google, as I just did, for suggest projectile velocity, all one word. Look at these two results, the gameplay statics and the other one, which I have on the screen now. Make sure you've got some idea of how that works. Recap what I showed you back here with regards to these arcs and the velocities, and just mentally prepare yourself that you understand what we're trying to do here. One gotcha is understand that toss velocity is an out vector, an out parameter rather, and that it's a bit odd to give us the velocity out. I'd rather it give you the direction out, because the size of this toss velocity is constrained by the toss speed. So actually the only information coming out of toss velocity is the direction of it, if that makes sense, because it's always going to have a length of toss speed. But we can deal with that ourselves. So make sure all of what I've just said makes sense, and I will see you in the next video where we actually use this method in anger or joy. Anyway, see you there.